Hi, now we will look at the proof of Pythagoras theorem, right? So what is Pythagoras theorem? The hypotenuse square is equal to the base square plus the height square in a right angle triangle, right? So if you put it in words as given in your textbook, it is like in a right angle triangle, okay, the square of the hypotenuse will be equal to the sum of the square of both the sides, okay, other two sides, okay. So if you take a right angle triangle like this, this is a right angle triangle, right angled at B, okay, this is B. So A, B, C, we have a right angle triangle. Now what they are saying, in a right angle triangle, the hypotenuse square, that is AC here, right? AC is the longest side in this right angle triangle, that is a hypotenuse, will be equal to, so AC square will be equal to sum of the square of other two sides. Other two sides means base and height, okay. So what is base here? You can see AB. So AB square plus BC square, and this is what we need to prove, okay. So AC square, that is a hypotenuse square, is equal to base square and height square, the sum of the squares of other two sides. This is what we need to prove in the session. So how will you prove? We have a right angle triangle. So from the previous theorem, what you understood is, if you draw a perpendicular from the vertex of the right angle in the right angle triangle, okay, like this. So you draw a perpendicular, okay, from the vertex of the right angle in a right angle triangle, you will get two right angle triangles, AB, and this point is D, ABD and BCD. These two are similar. That we already understood, okay. So you can first write as a proof, okay. So we are going to prove this theorem. So proof, the first point that you can write as, draw BD perpendicular to AC, okay. So BD perpendicular to AC. And what is the reason? Reason you will write construction, okay. Reason you will write construction. Now after that, what you will do? You take this small triangle which is ADB, okay, and also triangle ABC. We know ADB and ABC are similar. We have just proved it now. So you can write triangle ADB similar to triangle ABC. So we just proved it, okay. So theorem 6.7. If you want, you can write the theorem 6.7 that you have learned. So here we are discussing your theorem 6.8, okay. This is theorem 6.8 in your chapter 6, okay. So we have learned this ADB and ABC are similar in the previous theorem. So if two triangles are similar, their corresponding sides will be in the same ratio. Now if you look at these two triangles, what are the corresponding sides? You can see the hypotenuse of ADB is AB and the hypotenuse of ABC is AC, okay. So AB and AC ratio, okay. So what you can do is the ratio of corresponding sides, AB divided by AC, which will be equal to, so what is AB? AB is the hypotenuse of the small triangle and AC is hypotenuse of the large triangle. So corresponding sides means hypotenuse, okay. Then we need to take the base, okay, base of each triangle. In case of smaller triangle, what is the base? AD is the base. And in case of larger triangle, what is the base? AB is the base. So you can write AD divided by AB, okay. So you can see AB is common here, but what is this AB? This AB is the hypotenuse of the smaller triangle. But when it comes to here, this is the base of the larger triangle, okay. So AB is actually common in both. Why? Because AB is the hypotenuse of the small and AB itself is the base of the large. So I hope you understood this. So from this, what you can write? What you can do is you can take this AB here and you can take AC here. So you can write AD into AC is equal to AB into AB, which is equal to AB square, and keep it as your equation 1 or information 1 or whatever it is, okay. So I hope this much is clear. You draw BD, which is perpendicular to AC. Then we know these two triangles are similar, okay. That is a previous theorem. Then from that, we know the corresponding sides will be in the same ratio in two similar triangles. So we got this, okay. Now what you need to do is take this triangle, okay, and compare it with the larger triangle. So we know BDC is similar to ABC, okay. So triangle BDC similar to triangle ABC, again from the previous theorem, okay. So you can write from 6.7 previous theorem. So from this, what you can write, again the corresponding sides will be in the same ratio. So BDC and ABC, if you compare, what are the corresponding sides? Okay, you take the smaller triangle. What is the hypotenuse? Hypotenuse is BC. Okay, so hypotenuse of the smaller triangle is BC. What about the hypotenuse of the larger one? AC. So you can compare this. Okay, so these are corresponding sides. So what you can write is BC divided by AC. Okay, so BC is the hypotenuse of the small, AC is the hypotenuse of the large. These are corresponding sides. So BC divided by AC will be equal to, what is this CD? CD is the height of the smaller triangle, because this is a base, this is a height, and this is a hypotenuse, okay. So CD is the height of the smaller triangle BDC, and what is the height of the larger triangle? That is BC. So you can compare that, right? You can write CD divided by BC. So two heights. Now what you can do, take BC here and take AC here. So what you will get is, you can write AC into CD is equal to BC into BC, which is equal to BC square. Okay, so you can write this as second information. So first one is this, AD into AC equal to AB square, AC into CD equal to BC square. Now what we need to do is 1 plus 2, add 1 and 2, okay. So 1 plus 2, if you do, what you will get, AD into AC, that is the LHS of this, AC into CD, that is the LHS of this, okay. So AD into AC, okay, then AC into CD, so plus AC into CD equal to, here AB square, so AB square plus BC square, okay. So AD into AC plus AC into CD equal to AB square, okay, and then BC square, okay. So AB square plus BC square is what you will get. Now you can see AC is common in here and here. So you can take AC out, then you will write AD plus CD equal to AB square plus BC square, okay. Then what is AD plus CD? Look at this. This is AD and this is CD. So what is AD plus CD? That is AC. So what you can write here, AC into AC equal to AB square plus BC square, right? Then what is AC into AC? We can write it as AC square is equal to AB square plus BC square. And that's exactly what we wanted to prove, right? So this is where we started. AC square is equal to AB square plus BC square. So what is AC? AC is the hypotenuse. Okay, what is AB? AB is the base. What is BC? BC is the height. So what was the theorem? Hypotenuse square will be equal to base square plus height square. Or in a right angle triangle, the hypotenuse square will be equal to the sum of the square of other two sides AB and BC. That's the theorem. Okay, so we proved the theorem. So what we did is, we just dropped this perpendicular. That's where we started. When you draw this perpendicular BD, which is perpendicular to AC, you will get here a right angle, right? So from that, you understood that triangle ADB similar to triangle ABC, previous theorem. Then triangle BDC similar to triangle ABC, previous theorem. Then when you equate the corresponding sides of the similar triangle, from the first you got this information, and from the second you got this information. When you add both, you will be able to solve or prove this theorem. I hope all of you understood this.